Hello everyone and welcome back to our channel mootechie. It's great to have you with us for the second class in Unit 5 on mixing and agitation. Today we will build on the fundamentals from our last session and dive into more specific techniques and considerations for effective mixing. Let's begin by discussing methods to avoid the formation of a vortex or swirling in an agitated tank. This is important because a strong vortex can reduce mixing efficiency and even damage the agitator. One method is to use a tilted impeller shaft. Another is to mount the agitator eccentrically, meaning on the side of the tank rather than directly in the center. The most common method is to use baffles. Baffles are vertical strips placed perpendicular to the wall of the tank. Usually 4 baffles are sufficient. For turbine-type agitators, the width of the baffle should be less than 1/12 of the tank diameter. For propeller agitators, the baffle width should be less than 1/18 of the tank diameter. It's worth noting that side-entering, inclined, or off-center propellers often do not require baffles at all. Successful agitation is achieved when the radial and longitudinal velocities imparted to the liquid are maximized. This can be accomplished through the use of baffles, by having an off-center or angled mixer shaft, or by using impellers with angled blades. A diagram shows how the position of the agitator affects the flow patterns for effective mixing. While agitation is necessary, excess agitation must be avoided. Over-agitation can cause product damage by disrupting the fat globule membrane in milk. This exposes the fat to the lipase enzyme, which can lead to rancidity. Furthermore, over-agitation can cause the formation of butter granules, which is undesirable in most liquid milk products. Now let's talk about draft tubes. A draft tube is used to control the direction and velocity of the flow towards the impeller. It is particularly useful when high shear at the impeller itself is desired, such as when creating emulsions, or for keeping floating solid particles submerged. However, draft tubes have disadvantages. They add to the fluid friction within the vessel and can reduce the overall flow rate generated by the impeller. Draft tubes can be designed for different agitators. There are specific configurations for turbine agitators and for propeller agitators. In a typical setup, the draft tube is a vertical cylinder surrounding the impeller, often with baffles on the outside of the tube. Selecting the right agitator depends on several factors. You must consider the viscosity of the liquid being mixed. The dimensions of the agitator, particularly the impeller diameter relative to the tank, are critical. The agitator speed and the power requirement are also key calculations. It's important to assess the potential for vortexing and to understand the requirements for heat transfer if the vessel is jacketed. The selection of a mixing pump is equally important and depends on the fluid's properties. Centrifugal pumps are good for low viscosity, clean fluids and steady flow rates, but they are not suitable for viscous fluids, fluids with solids, or shear-sensitive fluids. Piston or diaphragm pumps handle viscous fluids and high pressures well and offer precise control, but they cannot handle fluids with solid particles. Rotary viscous and shear-sensitive fluids with precise flow control, but they are also not for fluids with solids. Single rotor pumps can handle viscous fluids, fluids with solids, and are gentle on shear-sensitive products, but they are not for high-pressure applications. Monopumps are similar, good for viscous and shear-sensitive fluids, but they cannot handle solids or high pressures. Peristaltic pumps are excellent for viscous fluids, fluids with solids, and shear-sensitive products, and they offer good flow rate control, but they are not suitable for high pressures or high flow rates. Finally, let's look at some specific applications of agitation in the dairy industry. Agitation is crucial in the production of yogurt to maintain a smooth texture. It is used in processed cheese manufacture to ensure a homogeneous blend. In ice cream making, agitation is key during aging and freezing. Cream storage tanks require gentle agitation to prevent fat separation. Agitation is also necessary in tanks holding milk and whey concentrates to avoid settling. Finally, effective agitation is essential for the proper dispersion of powders into liquids. Thank you for joining this session on advanced mixing concepts. We've covered how to control flow, avoid problems, select equipment, and seen real-world applications in dairy processing. This knowledge helps ensure efficient and high-quality product manufacture.